So in physics, units are very important because we'll be dealing with a lot of physical quantities, things like volume, distance, speed, that all need to be expressed in units. After all, if you have 300 grams of M&Ms, that's way different from having 300 kilograms of M&Ms. So whenever we write down a quantity, we want to include units. And it's very important when you do quizzes and exams that all of your quantities are expressed along with units. Now, all units can be expressed in terms of fundamental units, and these are things like length, time, Kelvin temperatures, moles, and meters. And so, for example, an area is a length squared, or a square meter in the SI system, and speed would be length divided by time. Think meters per second or miles per hour. Now on May 20th of 2019, which was actually during one of the summer physics sessions previously, the SI system was revamped and we have new definitions of some of these fundamental SI units. This is because there was a problem before that some of the fundamental SI units were based on things like a lump of metal in a vacuum jar in France. And if you have a lump of metal, well, an atom could fall off of it, and then your very definition of a kilogram would change. And these definitions weren't precise enough for the very sophisticated measurements that scientists are capable of making these days. And so all of the fundamental units were tied to constants of nature, things like the speed of light. And because they're now tied to constants of nature, as instrumentation gets better and people are able to measure things more precisely, then we don't have to worry about our fundamental units being imprecise. So this doesn't really affect us, this change in the SI system doesn't affect the calculations we'll be doing in general physics because we won't be carrying out measurements of very, very high precision. But it's just kind of neat to know that the system was changed and that all of the constants of nature are now used to define these units. Now, as we mentioned before, in physics we are describing everything from atoms and particles to galaxies. And so we need to express very wide ranges of numbers. And one of the things that helps us to do this are unit prefixes. And you can see here a table of unit prefixes. And the way that these prefixes work is that when you add them to a measurement, then they imply multiplication by a power of 10. So for example, a centimeter, if we look on the table, we see centi means 10 to the minus 2, so 1 centimeter would be 1 times 10 to the minus 2 meters, or 0.01 meters. On the other hand, 3 kilometers is 3 times 10 to the third meters, or 3,000 meters. Now, one question I always get asked during class is, do we have to memorize this whole table of unit prefixes? And the answer is no, you don't. The most important ones are centi, milli, and kilo. So you should know how many centimeters are in a meter, you should know how many millimeters are in a meter, and you should know how many meters are in a kilometer. So you should be able to go between centi, milli, and kilo. Those are the ones you should memorize. The other ones on this table, if they pop up in an exam or quiz situation, I will give you their definitions. Another thing we need to be able to do with units is to convert them from one form to another. So let's take an example. Let's say you can pour a glass of milk in 5 seconds, so you know your pour rate is 1 glass in 5 seconds. So 1 glass in 5 seconds, which is equivalent to 0.2 glasses per second. And you want to be able to convert this to cubic centimeters per minute. So here we have a volume, a glass per second, so that's time. And here this is a different volume per time that we want to convert this number to. So how would we do that? So as you may have learned in other classes, what we need to do is multiply this 0.2 by some conversion facts. And maybe I don't know how many cubic centimeters are in a glass, but I know some intermediate facts that I can use to help me along the way. The important thing is when you are arranging these conversion facts, you arrange them so that the unit that you don't want, in this case glasses, gets arranged so one is in the numerator, one is in the denominator so that they can cancel, and then that would leave you with cups. So to change this volume measurement from glasses to cubic centimeters, one fact that I know is that a glass is 2 cups. So I'll arrange it like this so glasses cancels with glasses. And then I also know that there are 16 cups in 1 gallon. So once again, cups would cancel with cups. And another conversion fact that I can look up is that 1 gallon is equivalent to 231 cubic inches. So here, once again, gallons can cancel with gallons. And then another fact is that an inch, 1 inch, is equivalent to 2.54 centimeters. And here I need to cube things because I have cubic inches here, so that needs to cancel with cubic inches down here. And then the centimeters can also get cubed so that my final answer can be in cubic centimeters. So now that I've changed glasses to cubic centimeters, I also need to convert seconds to minutes. So seconds is in the denominator of my original quantity, and so I need a conversion fact that will go between seconds and minutes. So 60 seconds is equivalent to 1 minute, and seconds can now cancel with seconds, and I'm left with cubic centimeters per minute. So when I do this conversion, what I'll do is I'll take the 0.2, multiply it by 2, so 0.2 times 2 divided by 16 times 231 times 2.54 cubed. I have to be careful and remember that the cubed doesn't just cube the centimeters and the inches, but also cubes the numbers as well. 1 cubed is still 1, but I have to multiply by 2.54 cubed. Then I multiply by 60, and the final result is 5.7 times 10 to the third cubic centimeters per minute. So here's a question that you can look at. Let's say you know that a camel can drink 20 gallons of water at a time. Let's say you have 600 liters of water and you wish to store your water in camels. How many camels would you need to drink this much water? And as an intermediate conversion fact, I know that 1 gallon is equivalent to 3.786 liters.